We have discussed that there are two main types of weft knitting machines, but here we'll dive into them more. Circular and flat machines are both capable of weft knitting, but each has its own benefits and drawbacks. Circular machines are the most common type of weft knitting machine, and they are highly productive. The cylinder rotates quickly without stopping, and with each rotation, one course of knitting is produced for every yarn feet on the machine, so a great deal of fabric can be produced quickly. For this reason, these machines are used primarily to produce yard goods from which items will be cut and sewn. These machines can range in diameter from 3 inches all the way up to over 60 inches, with smaller sizes being used for hosiery and body size knitting, where an item such as a t-shirt can be produced without side seams. The largest sizes are used for home textiles, such as knit sheeting and mattress ticking. Because the yarn is being fed with so many ends at once, the resulting fabric forms as a spiral, which combined with the singular direction of knitting, can contribute to skew in the final fabric. However, several techniques can be employed for managing skew. The most basic of these machines are single knit machines, which contain only one set of needles around the cylinder of the machine. Single knit machines have sinkers between needles to help control fabric formation. Due to the combination of different stitches and the arrangement of high and low butt needles, they can still produce a variety of fabrics, but there are limitations. The arrangements of yarns in the creel can be used to create stripes in the fabric. Double knit machines have a second set of needles located on a dial placed on the top of the cylinder. The space between the cylinder and dial is called the dial height and is tightly controlled as it contributes to fabric thickness. Double knit fabrics tend to be thicker and more stable than single knits and have less curl because the stitches from the two sets of needles help balance the knit structure. Having two sets of needles knitting simultaneously allows for greater range of patterning in a fabric. While only one set of needles on a double knit machine could be used to produce a single knit fabric, doing so would be an inefficient use of the equipment. Additionally, since a double knit machine does not have sinkers, the fabric quality would be subpar. Clearly understanding which type of machine is needed to produce a fabric is crucial in conversations with suppliers to better assess the capabilities of the machinery you are working with. There is a wide variety of circular machinery in the industry, and some machines are highly specialized. One such type is referred to as a seamless machine. These machines tend to be small in diameter, close to body size, and often feature advanced patterning capabilities. These machines can produce finished start and ends to pieces and can also reciprocate, meaning the cylinder moves back and forth instead of continuously rotating, which allows for added shaping. These machines can be used to produce fabric pieces that will be finished into final items such as belly bands, sports bras, compression garments, shapewear, and athletic wear with minimal seams. Contrary to their name, many of these garments still require some seaming to be finished, but they do not require as much seaming as standard cut and sew items, which can contribute to greater comfort for the wearer. Similar to seamless machines are sock machines, which are very small, ranging commonly from 3 to 6 inches in diameter. These machines start a sock with a finished edge called a welt and often reciprocate to shape the heel and toe of the sock. They may feature advanced coloration and patterning capabilities, and advanced machines can even close the toe of the sock on machine, creating a finished product which only needs to be washed and finished. While circular machines are highly productive, the width of the fabric is largely set by the diameter and gauge of the machine, although it can be changed slightly through stitch length and type. Flatbed machines, on the other hand, allow for the number of needles in use to be selected, with more needles producing a wider fabric and fewer needles producing a narrower one. They are much slower than circular machines because the carriage must stop at each end of the knitting to return in the opposite direction. Additionally, only a small number of courses of fabric are produced at a time, depending on the number of cams on the carriage. However, what they lack in speed, they make up for in versatility, being able to create complex and unique shapes. Flatbed machines are commonly used to create sweaters, gloves, shaped knits, and specialty items such as shoe uppers and even medical and automobile devices. They are not commonly used to create yard goods except when very complex fabric structures are required. Flatbed machines typically have two sets of needle beds, arranged from 90 to 120 degrees to each other in an upside-down V shape, which is where they get the name V-bed. These two sets of needles can produce flat knit fabric structures, but they can also produce tubes of fabric by knitting first along one bed and then on the other on return. The beds can work together to create complex shaping without the need for cutting, and they enable stitch patterns that are not possible on circular machines. Flatbed needles contain an extra piece called a transfer clip, which allows the needles to pass a live stitch between them, transferring it from one bed to another. The two beds can also move past each other in either direction, a process called racking, which allows for increasing or decreasing stitches at the edge of the fabric to create shapes. This transferring and racking capability can also produce complicated knit structures, such as cables and pointelles. Some flatbed machines have multi-gauge capabilities, allowing for a wider range of yarn sizes and knitting techniques. The yarn is carried in feeders that run on rails above the knitting elements. These feeders are either pushed by the carriage as it moves across the bed or are operated by individual electronic motors for faster knitting. Multiple feeders can be used simultaneously, enabling the creation of shaping around a neckline or multiple sets of sleeves. Each piece of flat knitting is started with a cast-on of waste yarn, which is pulled by a cast-on comb until the piece is long enough to interact with the takedown rollers. A separator thread is then used to separate the waste yarn from the knitted piece, allowing multiple pieces to be knit in sequence with separator threads between them. This ability to shape leads to a reduction in material waste and results in high-quality, well-fitting garments. Some flatbed machines can knit integral goods, entire garments without the need to cut and sew or seam. For example, a sweater might start as 3 separate tubes knitting simultaneously, which then join together to form a single piece, shaping the chest and shoulders before finishing off the neckline. These items are truly seamless, with very little waste. While basic seamless garments can be created using simple structures on only 2 needle beds, some machines feature a second pair of needle beds to allow for advanced patterning.